Hello and welcome to the new year, 2nd of January 2024. When I read this problem, I immediately thought of proposition 19, and I had to restudy the proof, and there was no character needed there. So why that? And then the next thing is the cusps. They only used the cusps at infinity and naught. How could that be? And then I realized that in proposition 19, all the values of n were prime, as they are here. And there we know the cusps. That was the last problem of section 1. I'm not sure I was aware of that when I read it the first time. But let's check what are the values of k here. (24 divided by 8). So you see they are odd. And then I went back to look at the proposition, and they were all even. And that means that when we operate with minus I, then it becomes minus f of z, because k is odd. And that only gives the naught function, meaning that we might have functions lying in gamma naught of level n, but not in gamma naught, because there minus I would be as well. So that's where this comes from. And now the proof carries over. I don't see any problem at all with any of the details. So what I would like to prove instead is, or not prove, I would like to see if I can prove that these guys actually lie here. The first thing I would like to prove is that it is a cusp form, of course. Oh, that's not obvious. We need to check the value at naught. Oh, that follows from the proposition 19. The same proof will carry over. So it's a cusp form of gamma 1 of n. So that's what I'd like to prove. So first there's conditions at the cusp. And that follows just like in proposition 19, I think. So it's only the transformation So we need generators of gamma 1 of 7 and 23. Can't do. We don't know those. So let's instead try to raise f to the to n plus 1. So we define a new function. This guy is a cusp form of order 24. No, yeah, oh yes, of order 24. And this, yeah, I'll just be very precise here. We have delta equals 2 pi to 12 eta to 24th. And then what this is, oh, it's delta to 24th of n z. And that means that that was proposition what? Is it 17a, I think? I've done my homework, you can see. Yeah, 17a. This is a cusp form of order 24 of the congruence group gamma naught of n. And this, of course, there's something wrong here. It's S12, isn't it? It's of level 12. And that means that this guy lies in S24 of gamma naught of n. The question is, when we take the root, how we can prove dependence yeah. So I can't handle it because I don't know the generators. I believe we have the generator T and 1,1n. And then we have minus unity, of course, which is why this is introduced. But we know there are more. Because this generates the Hecke group, and we know it's not a group of modulo n, so it's not a modular group. That's disappointing. I had hoped that I would be able to do more than mimic the proof of proposition 19.